Good afternoon or good morning, depending on where you're listening from today, and welcome to TME Presents Building for a Resilient Future. You've read the article, now learn the rest of the story. I'm Daniel Wheatley, the Associate Editor for the Military Engineer, and it's my pleasure to welcome you here today. Before we get started, though, I'd like to go over a few items so you know how to best participate in today's event. All of our attendees are in a listen-only mode for the presentation, but you can use the chat pane to chat with your fellow attendees. Let's try that now by everyone typing in where we're listening from today. You can submit questions for our presenters at any time by using the questions pane of the control panel. We will collect these and address as many as we can during the Q&A session at the end of the presentation. Please also submit any technical issues you may be encountering here as well. Originally published in the November-December 2021 issue of TME, Building for a Resilient Future discussed how NAVFAC is institutionalizing modifications to current design standards and construction practices through updates to unified facilities criteria to increase resiliency. We'll hear more about that effort and how resiliency criteria efforts are aligning NAVFAC Atlantic with the recently released Department of the Navy Climate Action 2030 in today's presentation. I would now like to introduce today's panel of NAVFAC experts. We are joined today by Sherry McMillian, Engineering Criteria and Programs Director, Kristen Brennan, Resilient Infrastructure Criteria Manager, Nate Manning, Community Planner, Brian Hardman, Community Planner, Robert Warren, Civil Criteria Manager, Michael Lewis, Senior Landscape Architect, and Michael Partica, Utilities Operation Management Energy Security Mobile Utility Support Equipment Director. Before we hear from them, however, it is my honor to welcome Rear Admiral Lori Aguayo, Commander, NAVFAC Atlantic, to the digital stage for her opening remarks. Admiral Aguayo, thank you so much for being here today. I look forward to your remarks.
Daniel, thank you so much for that kind introduction, and good afternoon to everybody who has joined us today. I want to thank you so much for being here and for taking this interest as we deep dive into the NAVFAC's Building for Resiliency. So let me talk a little bit about what we're doing here in the Navy. Our top leaders are fully aligned and engaged in tackling the nation's climate change challenges and incorporating climate initiatives into the Department of Defense. The Secretary of the Navy, Carlos del Toro, has named climate change as among the most pressing challenges facing the Navy and the Marine Corps and is a key element to maintain maritime dominance. Climate change is one of the most destabilizing forces of our time. The Navy and the Marine Corps are most certainly impacted by the climate crisis. The threat increases in stability and demands on our forces while simultaneously impacting our capacity to respond to those demands. Climate change also increases risk to our people, installations, our training ranges, platforms, logistics, and operations, and it impacts the mission sets our forces must support. It is a national security and warfighting imperative for the Navy and the Marine Corps to address the impacts of climate change on our readiness, operations, and ability to fight and win, while increasing lethality, agility, and survivability. The Department of the Navy has now released the Climate Action 2030, as Daniel just mentioned, which articulates the department's approach to building climate-ready force, which is resilient to climate impacts, while being manned, trained, and equipped to fight and win around the globe in the evolving climate and security landscape. Climate Action 2030 also communicates the department's commitment to reducing its contribution to climate change and achieving the national target of reaching net zero greenhouse gas emissions by 2050. This strategy will help our Navy and Marine Corps take more coordinated, decisive actions to reduce our contribution to climate change and build climate resilience. The panel here today, comprised of members from NAVFAC Atlantic, the NAVFAC Criteria Office, and NAVFAC Headquarters, will discuss recent and future efforts to tackle these climate change issues and build resiliency into our Navy and Marine Corps infrastructure. I'd like to now turn it over to Sherry McMillian, our Director of NAVFAC Criteria Office, and I really hope you enjoy the presentation thank you so much for taking time today to learn more about our enterprise-wide effort. So I'll turn it over to Sherry.
Thank you, Admiral. That was great. Before we dive into the details, I'd like to provide a quick overview of resiliency and how Dod Criteria has strategized to integrate resiliency into our planning, design, and construction criteria. So next slide, please. There we go. Resiliency is defined as the ability to prepare for, withstand, and respond to and recover from a man-made or environmental event or disruption. We need to identify potential threats, what risks they pose, and mitigate that threat to the level needed in order for us to maintain our mission readiness and operational capability. We also need to be able to recover from the threat as soon as possible in order to continue our operations and our mission. Next slide, please. When we talk about threats, we're not just looking at floods and earthquakes, but all of these things. It encompasses a lot more. We look at man-made threats such as chemical or explosive attacks, climate change effects such as sea level rise, which causes flooding, extreme weather events such as tornadoes and hurricanes, and technology changes such as cybersecurity threats, which we've recently experienced here in the US. We also look at weapon platform changes. Are our building systems and criteria flexible enough to handle new systems in development and use? Right now, we have a lot of drone technology as an example. So next slide, please. This is our Dod Criteria Strategies. So it contains UFCs, which are the building and infrastructure planning and design requirements, and the Unified Facility Guide Specs, which are the construction requirements. We look at criteria in this pyramid basically from the ground up, and we make sure it contains the requirements to mitigate the risk to our facilities and to our people. Resiliency is layered into each of these requirements as we proceed from planning to design all the way to construction. The codes and standards provide a minimum level of resiliency and protection and performance for us. You see those as the foundation of everything. For instance, the IBC provides resistance to wind and other threats with the minimum wind and structural load requirements. DoD further builds on these and increases resiliency with our UFC 12001, which is the DoD building code, which is the basis for all of our USC. And that provides an additional facility requirements to meet our DoD needs and increase the resiliency of our facilities. And then moving up, in addition to the industry codes and standards, we implement legislation, executive orders, policies, and other DoD and federal mandates, including those for resiliency, which you will hear more about later. We incorporate these in the core UFCs, which address building systems that are frequently used in every project, such as architectural, structural, mechanical, and electrical, and so on. They include more stringent building and infrastructure requirements than just the industry codes and standards, and this naturally adds a level of increased resiliency to our requirements. More durable and resilient building systems are also required depending on the location of the project. For instance, along coastlines, due to the severity of the environment at that location, for instance, from wind, salt, rain, temperature, and other extreme potential threats. And that's built into the UFCs and into the UFGSs, which leads to the UFGSs, which define the level of performance, resiliency, and quality of the building materials and systems used in the construction of our facilities. They provide the requirements that mitigate those threats to the level needed based on such factors as life cycle cost effectiveness, durability, and the performance of the materials, as well as the environmental factors present at the location of the project. Through all this, we continue to work on improving the resiliency of our facilities by applying resilient concepts across the board in DoD in the form of our UFCs and our UFGSs. So I also want to thank you for joining us today and appreciate your support in making our facilities more resilient. With that, I will turn it over to Ms. Kristen Brennan. She's the Resilient Infrastructure Criteria Manager, and she will go into more detail on all of this criteria. Thank you very much.
All right, next slide, Dan. All right, the resiliency criteria efforts align with the Department of Navy Climate Action 2030 focus. We're working on projects that will increase resiliency through nature-based solutions and to increase our energy resilience. These two focus areas will be discussed in more depth throughout this presentation. Next slide. The NAVFAC criteria group is part of a tri-service team. We work collaboratively with the Army and Air Force on an installation resiliency function group. This group spearheads some of our resiliency criteria projects across disciplines. Below is a list of our current FY22 and FY23 planned projects. This next year, we have a significant focus on microgrids for energy resilience. We're about halfway through our microgrid UFC development, and we'll be working on battery storage, controllers, commissioning projects for FY23. Cyber is also a concern we're working on for UFC, which includes the development of a communications facility UFC, which will help make our facilities more resilient. We are increasing our natural infrastructure criteria through the development of a new UFC that will have a design focus and will be complementary to the climate change planning handbook used by our Navy planners. This effort also involves collaboration with the Army Corps of Engineers Engineering with Nature program. In addition, we're increasing resilience to earthquake hazards by updating our seismic criteria that stretches across geotechnical, structural, and our waterfront disciplines. As we work towards our goal for zero emissions, we're creating a new electric vehicle supply equipment UFC, and we'll be updating our existing guide specification. This work will cover non-tactical fleet vehicles, privately owned vehicles, and tactical fleet vehicles. Finally, the Navy has an inventory of aging infrastructure. Past events have shown that our aging infrastructure is at greater risk than our newer construction. We have projects in place that will look more deeply into the performance of existing critical facilities and look into ways into increasing resiliency. Next slide, and we're going to go over to the planners.
Good morning, this is Nate Manning at NAVFAC Atlantic. Resiliency and planning criteria. We've had some recent updates to planning criteria and 2 DoD Unified Facilities Criteria documents, specifically UFC 2101 Installation Master Planning or Comprehensive Planning, and also the 05N or Facility Space Planning for Navy and Marine Corps installations. And UFC 2101 Installation Master Planning, 10 U.S. Code 2864 requires master planning for military installations, but also addresses energy and climate resilience, transportation, and installation resilience components of the master plan. The FY20 National Defense Authorization Act requires climate change effects and considerations be built into the master planning process. Per the law, in the military installation resilience component of the master plan, we utilize the NAVFAC Climate Change Planning Handbook for installation, adaptation, and resilience. The NDAA requires the use of the Department of Defense's Regional Sea Level Rise Database and the DoD Climate Vulnerability Assessment Tool for further climate-related analysis. In the 05N or Facility Space Planning for Navy and Marine Corps installations, this document addresses the basic facility requirements for mission assurance facilities. Programming projects with resiliency items built into the design protects mission essential assets. Next slide, please. The DERSAL database, or DoD Regionalized Sea Level Change and Extreme Water Level Scenarios, assesses vulnerability and impacts from climate events at locations where DoD has assets currently. The scenarios that are provided are adjusted specifically for each DoD site, so decision makers can make location-specific decisions. There are 5 scenarios within each time frame: 2035, 2065, and 2100. The end user must go through a series of scenarios to understand any potential change in shoreline or wetland areas. The end user must go through questions like, how impactful is this scenario? What areas are likely to see climate-related implications? And when might it happen? We are currently developing a decision tree to aid the end user through this process. We also recommend the end user generate maps for sea level rise with storm surge to understand temporary flooding that might occur in a specific location. The dorsal is available currently in data table format. However, NAVFAC is currently transforming the tabular data into GIS to better support decision making. Next slide, please. And I'm going to pass it over to Brian Hardman.
All right, thank you, Nate. This is Brian Hardman, and as part of the fiscal year 2020 National Defense Authorization Act, there was the requirement for a new section to be added to the master plan. And the master plan is also called an installation development plan. We do have a consistency guide that goes along with that. And so those new topics included, for resilience specific, the risk and threats overview, assets and infrastructure, lessons learned, ongoing and planned mitigation projects, outside the installation, public or private agreements, and future risk and threats to projects. And so these are all sections that have to be answered by every installation, and it makes them look at what they're doing for these topics and how does resilience play into that. Next slide, please. And so as it has been mentioned already, there's the Climate Change Planning Handbook, which covers installation, adaptation, and resilience. This was a 2017 publication that has just recently been given the ability to train the handbook to 8 different regions in throughout the world in NAVFAC. And so this is a tool that can be used that shows how the impacts on the build and natural infrastructure, and using this planning handbook for the development of tools, looking at adaptation and resilience from that standpoint. Next slide, please. And so as I mentioned, there are 8 trainings located worldwide, and those trainings will be done in 4 stages because the handbook is in 4 stages. So the first one is establish scope and characterize impacts. Stage 2 is identify the screen action alternatives. And then stage 3 is calculate benefits and costs of action alternatives. And stage 4 is assemble a portfolio of action alternatives. And along with that, the appendices also include some topics such as adaptation, action alternatives, fact sheets. And so those go into a deeper dive into structural adaptation approaches, natural and nature-based adaptation approaches, facility adaptation approaches, non-facility adaptation approaches. Then there's another one that talks about the economic analysis tools and resources fact sheets. There are worksheets that every student that goes through the training works through one. They all come together and decide what scenario they're going to look at as a group. And then the worksheet then goes through stage 1, 2, 3, and 4. And you're able to, at the end, have this idea of what's going on. And so this is helpful when you're planning projects such as MILCOMs, because when you're looking at, with this proposed project, how can the climate change planning handbook play into an alternative? Well, here's the worksheet that moves you through stage 1 through 4, and you can then have another assessment for that MILCOM project. And so, as I mentioned, we have 8 trainings. There are 6 that are planned in person. We already had 3 starting last November, and then we have 3 more coming up this summer. And due to COVID, we have 2 that have turned into virtual, which is in some ways very unfortunate because you have so much interaction between the students as they're doing the different exercises as a team and as a group. And so doing it virtual, they now have to learn how to use other tools to then still come together as a group. But the point of doing 8 different locations is not every situation will involve sea level rise. You might have Southwest might be dealing with fires, maybe tsunamis or earthquakes, and then maybe the East Coast is dealing more with the flooding and storm surge. But then you might have places in Far East that have to deal more with earthquake or tsunamis. And so as we have the different trainings in those locations, the students agree upon projects and scenarios that fit them the best. And so the planning handbook definitely looks at how these different scenarios can be tailored to that location. And so each training has between 30 and 36 people that are enrolled for in-person, and we're keeping it about the same for virtual, just so that you can manage the groups that way too. And the training is open to asset management, environmental, design and construction, the CPLOs, which that person is the liaison between the installation and the community, and then also open to the Marine Corps. In addition to that, for those that maybe don't want to take the 3-day course, they may just want to say, you know, let me get an overview of what this planning handbook is. There is, in addition to this project, a 1.5-hour overview online course being developed, which will then have people that maybe just can't do those 3 days, they can take the course and get an idea of what it is, and then know how to implement the planning handbook with projects. Next slide, please. And so I mentioned the 4 different stage titles earlier, stage 1, 2, and 3, and 4. And so these are all, there's been the question of how can we put these into our master planning process as we develop our IDPs. And right now, the look is putting that in the analysis section. But as we have more guidance, we have more resilience, there's more things that are being brought to the forefront. As this is an evolving topic, you know, we look at also how can we include resilience in the master planning process, but then also how can the climate change planning handbook be brought into these projects such as mitigation or future projects, how can that be used? And so some of those 7 sections I mentioned a little bit ago will have the use for the climate change planning handbook to be used. And it may not be the master planning process, but it could be that MILCOM project, and you bring it in that process too. But for master planning, we're looking at more the analysis as you're gathering the information and putting everything together. Next slide, please. I believe that was my last one. Yeah.
So hi, this is Robert Warren, and I'm going to be talking about the developing the sea level rise criteria for civil engineering. So I had the opportunity to work on developing some new criteria to implement the DERSAL database, which Mr. Nate Manning already gave a brief intro to. But for this criteria development process, you know, we focused on tidally influenced areas, and we established default DERSA values in the absence of overriding component policy. And these default values were based on the building classification that was already included in ASCE 2414, which was flood resistant design and construction, and the risk to the facility. So this revised approach was coordinated with United States Army Corps of Engineers and the Air Force Civil Engineering community. It implements the FY19 Freeboard Approach, which was another modification that we made to the ASCE 2414 standard, as well as the FY20 approach, which was implementing the DERSAL database, which required some additional modifications to ASCE 24. And we took all this, we took all these criteria and published the DERSAL, the sea level rise criteria using the DERSAL database in UFC 3-20101 Civil Engineering Change 4, which was published in September of 2020. And UFC 3-20101 is one of the core UFCs that Mrs. Sherry McMillian was speaking of earlier. Next slide, please. So here's a table that basically gives you all the information you need to establish your design flood elevation, which is going to be the elevation that your finished floor needs to be at or above to help reduce the risk of flooding. And so on the far left of this table here, you can see the ASCE flood design classes. But it's important to note that what's shown in this table is part of the modification that I was talking about earlier. ASCE has flood design classes 1 through 4. And as part of this criteria development process, we established, we took category 3 and turned it into 2 categories. So there's a subcategory 3A and a subcategory 3B, and that's one of the modifications I was just mentioning a minute ago. And then in the middle column here, you can see the freeboard approach. And so as you proceed down this table in your flood design class, your building becomes more critical and there's a more risk involved. And so as the freeboard approach just goes down here, you can see we have a base flood elevation, which is the elevation that comes off of the FEMA flood insurance rate map, and a freeboard value, which for categories 2 and 3 is plus 2 feet, 3A, and then for 3B and 4, it's plus 3 feet. And this was part of the modification that we made to ASCE 24 as part of the FY19 NDAA. And as you move over to the last column on the right is where we start to introduce the dorsal approach, which is, which was what we developed to comply with the FY20 NDAA. So up in the top right corner there, you can see the dorsal sea level rise curves, and you can tell that these are color coded over here on the right. And so what happens is they match up with what's shown in this table. And again, as the risk increases, we chose a higher sea level rise scenario. Now, these are the default values that actually the default values would be 2065, but the lowest, low, medium, high, and highest. And so as your building becomes really critical, like for a pier or a dry dock or something like that, it's really essential. We would use the highest value in the dorsal database. And so when you're determining your design flood elevation, you have to actually run both of these calculations and look at them side by side and determine which one is the more stringent. And that's going to determine what your design flood elevation is for your facility. Next slide, please. So here in this slide, you can see the approach where the dorsal approach is the more stringent approach. You're looking at the two side by side with the freeboard approach. You have your base flood elevation. There's some datum adjustments that you have to take into consideration when you do this. And so as we start with mean sea level, typically your vertical datum is going to be some distance above or below mean sea level. For this example, we used NAVD 88. And from there, you can take your base flood elevation and add your freeboard to get your design flood elevation on the right side here. And then on the left side, shown in green, same type of scenario. You have to start with mean sea level, but then make an adjustment to get to the same vertical datum. You can look at your extreme water level, which comes from the DERSAL database, and add in your sea level rise value to determine your design flood elevation. And so in this, like I said earlier, this particular picture graphically represents the location where the DERSAL approach is the more stringent approach. But it gives a good visual of looking at the two side by side, the two different approaches, and developing those design flood elevations and determining which one is more stringent. With that, I'd like to turn it over to Mr. Mike Lewis.
Thanks, Rob. I appreciate that. I'm Mike Lewis, landscape architect at Atlantic, and what I'd like to do is talk through looking at using the nature-based resiliency engineering design, taking a look at how in the UFC do we incorporate it so that our projects, both master planning and environmental restoration, site-specific projects, can be handled and can be really set a baseline for what the Navy is looking at doing. We have a few executive orders that we're following. There are things that a lot of the policies that we're going to be working into these documents, and a lot of cross-business line coordination. I call it integrated design, and it's not just design and construction disciplines, but environmental, energy. I mean, there's a lot of opportunities for us, and it's not just the Navy, but it's also the tri-services are working together on this. Let's do next slide, please. This is an example project that we started. It's in Naval Base Dam Neck here in Virginia. The intent was to do an entry control point for the DevGuru compound. It's sited on an existing main drive in, but it is in the secondary dune exposure, surrounded by wetlands, existing development already. So it was something that we really had to kind of work with sensitivity to the environment. And you can see on the upper right, you see the beach zone. Then you would go back to the left, the frontal dune, the secondary dune, and where you see the actually label the entry control point site was the intent. Actually, originally it started right where that the wetland is right below it, but trying to incorporate that as well. We were making the adjustments on the site with multiple disciplines, and environmental and security was a major issue as well. Next slide, please. This is a graphic that we prepared for the RFP, basically showing the entry control point. We, everything that a main entry control point has needed to be included. So that was the visitor center for passes, security. We had to have some warehousing, so there was truck access to it. Then you get into the inspection station, where it's just right above the word inspection. You'll see that was a canopy for truck inspection. It had to be secured visually from the rest of the entry control point. So everything that the entry control point has needed to be incorporated all in a very constrained site. Again, I'm still showing you the secondary dune exposure just to the right of the visitor center. We also included the lid features, and it was a fine line. And on the left-hand side, where you see wetland and lid feature, that dash line was our limit of wetland that we could not encroach. and the lid feature fit within that area. That line was not altered during our development. You also take a look at the very left of the visitor center. You'll see that cluster of what looks like some trees. Those are actually natives that were existing in the wetland. So we maintained that wetland as existing and worked our features in around it. Next slide, please. And this is what it looks like today. And again, I think I did not mention that this was started in 2012. So it's good to see that, where we already have environmental projects, revegetation, restoration projects working, design and construction, or MILCON projects are trying to incorporate the natural infrastructure where we can, but it would be good to be able to have that opportunity, take that opportunity that wherever we can fit, whether it's a large master planning project or site specific like this one. This is what it looks like today. The visitor center, the entry plaza, POV parking for visitors, the inspection facility, wetland lid features, and then with little disruption to the secondary dune, you can see a little bit the little what do I want to say? Almost the pattern of the replanting of the secondary dune natural vegetation. You can see it around the visitor center, where the lid features went more to a native or naturalized grasses because of the function of the lid feature. But ultimately, this is I think a good example of where we want to head as far as making sure our UFC and some of our other documents include both site, really focus on the site specific as well. And with that, I'd like to turn it over to Michael to wrap it up.
Thank you, Mike. This is Michael Partica, NAVFAC Headquarters, Public Works Utilities. I'm the MUSE Director and Energy Security Program Manager. So resilient energy, I get to talk about one of the most exciting portions of the entire brief, in my humble opinion. And I'll go through these slides here pretty quick and have a couple questions for you, perhaps. The Department of the Navy will ensure energy resilience for mission accomplishment by deploying cybersecure microgrids or comparable resilient technologies to support its most critical missions. So one of the things I do as a energy security program manager is I leverage the mission assurance assessments and work with that team to find and mitigate threats to our energy sources. The installation of microgrids will leverage carbon pollution-free power generation and long-duration battery storage to the greatest extent practicable for continuity of operations of critical missions. Next slide. Microgrids for energy resilience. So a microgrid, you have to understand, first of all, what is a microgrid? It's an integrated system of electricity generation, distribution infrastructure, and energy storage is required to maintain power while disconnected from the commercial grid. And the FY22 NDAA, National Defense Authorization Act, says consideration of including energy microgrid in military construction projects, that's a must. So next slide. So we also have an executive order, 14057, catalyzing clean energy industries and jobs through federal sustainability. It establishes that the federal government will lead by example to achieve a carbon pollution-free electricity sector by 2035 and net zero emissions economy-wide by 2050, which sounds like a big deal, and it is a big deal. But your Department of Defense has developed tools. One of those tools is the Energy Resiliency Assessment Tool that can easily incorporate things such as incorporating technologies that are carbon-free, incorporating greenhouse gases that help us report for the policies and legislation that we have to report upwards on via the annual Energy Management Resiliency Report. Next slide. So one of the culminations of what we've done, back in December of 2015, NAVFAC published the P601, which is a microgrid design and reference guide. And now we're taking that, the natural progression of that is to take that P601 Public Works publication and turn that into a UFC. And that's going to provide all folks across the tri-services as well with a basic understanding of microgrid technology and a common methodology to identify requirements and develop conceptual designs. As part of the energy resiliency assessment tool that is required for ERSIP programs for military, that portion of military construction funding, the requirements in these conceptual designs are going to allow us to compare apples to apples and oranges to oranges and help us make better quantitative decisions in our processes. Now, there's previously mentioned was our EVSC, our electric vehicle supply equipment, which might mean commonly known as charging stations, that will encompass the conductors, including ungrounded, grounded, and equipment grounding conductors, and the electric vehicle connector, attachment plugs, and other fittings, devices, power outlets, or apparatus installed specifically for the purpose of delivering energy from the premises wiring to the electric vehicle. And that will be for non-tactical fleet vehicles, privately owned vehicles, and tactical fleet vehicles over time. So you can see to the right a picture of charging carports, and I think that is the last slide. But one of the exciting things here is we will have questions, but I'll have one question for you. We talked about climate change, and you heard about water scarcity, and you heard about high winds, seismic activities, inundation from sea level. But what's one of the things, and you can put it in the chat if you know the answer to this question, and that is, what is one of the new climate mitigation hazards that is becoming prevalent in the news, especially over on the West Coast? And I'll give you a couple minutes to put something in chat if you think you know the answer to that. Back over to you.
All right, thank you, Mike. Always great when we can turn the tables a little bit and ask some questions for the audience instead of them asking us. So with that, we are about to start the Q&A session in here. So before we do that, I just wanted to make everybody aware on the handouts tab, a copy of the slide deck as well as the PDH certificate has been made available for download. So if you want to take a look at anything in a little bit more detail that our panel has gone over, you can find it there. There's also a copy of the Climate Action 2030 that was just released for your reference. So for the Q&A, feel free to put your questions in the Q&A tab at any point there. And if you see a question there that you like or that you really want to see answered, hit the little thumbs up icon next to it to upvote it. That will help it rise through some of the other questions and get it higher up in the list here. So, so the first question that I kind of want to start with here is for Admiral Aguayo here. With the Climate Action 2030 just being recently released, are there any specific goals or targets related to this climate plan?
Thanks, Daniel. Yes, and I'm glad you're sharing the plan here with those participating so they can take a look at it as well. Yes, there are some specific goals that are listed, two major goals, and then some specific targets. But the reality is this is a big problem. The breadth and depth of the climate threat demands that we look at this holistically, and we take an enterprise-wide approach for the United States Navy, and it's going to take a sustained effort over time. But as previously mentioned, one of our goals is to achieve a net zero emissions by 2050. But then specifically, what are we looking at some of our targets? We discussed the nature-based resiliency and nature-based infrastructure. So what we're looking at is maximizing the use of natural infrastructure to build resilience and harness and harnessing nature to draw down an additional 5 million metric tons of carbon dioxide per year. So that is the rough equivalent of about 1 million cars taken off the road annually. Another one of our targets is energy resilience and installing cyber-secure microgrids or comparable resilience technologies to support our most critical missions. So we talked about that here at the end, about the importance of energy resiliency, microgrids, using and leveraging clean power generation and long-duration battery storage to the maximum extent possible. We also talked a little bit about our vehicles, and our goal is to acquire 100% zero-emission non-tactical vehicles by 2035. So by 2035, we will no longer be acquiring our fuel guzzlers. So hope by then the intent would be to be electrified in our non-tactical vehicles. Those are just some of them. There's some more detail in the plan. The next step, this is the Climate Action 2030 is a general strategy for the United States Navy. Obviously, this will be followed up with some more specific implementation plans that we, NAVFAC, will be working with the Secretariat and with OPNAV to help develop the actual implementation. Over.
Fantastic. Thank you so much, Admiral Aguayo. So let's get into some of these other questions that are coming in here. And this will probably be one more for Mike Partica here. A lot of questions, as expected, on microgrids and the electrification here. Mike, and of course, if anybody else on the panel wants to chime in here, feel free to as well. NK Baldwin here is asking, will microgrids be owned and operated by Department of the Navy, or are they going to be part of the utility privatization program?
So excellent question. This is Michael Partica. And it may be a combination of the both. It's as we build out microgrids, they will be owned and operated by the DON. You may see a hybrid approach where they're owned by the DON, operated by a contractor, or you may see, and we'll get to Tri-Fuel in a minute as well, but you may see a UP, utility privatization, where a microgrid is owned, operated, and maintained with the exception of the cybersecurity portion for the Navy through that UP partner. Hope that answers your question.
That's great. Thank you.
Yep.
So let's move over a little bit to, this is probably a question more for Michael Lewis here. Because I know natural infrastructure is, across all the services, is a growing effort here. I know I just was finished an article for TME about engineering with nature, the USACE sort of effort in this area. So, so for Michael, what do you see any sort of perceptions or obstacles that might need to be changed or overcome to integrate natural infrastructure into more designs?
Actually, I think one of the biggest things that I see happening is, we've never done this before, or, oh, this is new, how do we incorporate this? And it's not just our own engineers, it could be our A&Es that sign on for, down at Camp Lejeune, there have been discussions about, okay, we have projects that are aimed for natural infrastructure, but the local contractors are saying, well, we really haven't done this before. We have no expertise in this. How do we achieve this? And I think that's just something we need to work through. And to me, it is not a lot of it's not new stuff. These are things that we've been doing, site design with multiple disciplines for a long time. And the example I had, that was in 2012, and so this is, it is not a new, it's not a new industry. We just need to get them adjustment to, okay, this is what we expect. This is what you design to. This is what you build to. I think one of the other issues we'll wind up having is how do we get it funded? How do we have our planners incorporate that on an installation level into our 1391s? So, you know, we can make sure that that is funded properly and doesn't take money from other portions of the entire facility. And when I say facility, I mean building and site and everything that's related to that. I don't know, I feel like I was kind of rambling. Did that answer the question? I could keep going if you want me to.
I think so. I mean, if not, MK, if you've got a, oh, hold on, that was from me. I think if anybody's got some follow-up questions, maybe from Mike, we'll put them in Q&A here. But I want to keep moving on because we covered a lot of ground in the presentation today. And this is one probably for our community planners. But again, you know, anybody else, feel free to chime in if you've got some insights here as well. So this is one from Courtney here, who asks, is the DoD Climate Vulnerability Assessment Tool the primary tool for examining climate resiliency, or are you looking at other tools?
Hey, good afternoon. This is Nate Manning, community planner at NAVFAC Atlantic. I'll take this one. So the DCAT is a screening level assessment tool for exposure to extreme weather and climate related events. So I would say the DCAT is one of the tools that we're using in addition to tools like the DERSL that was mentioned in today's presentation, specifically for sea level rise or sea level change. So the DCAT is heavily right aligned for use with the DERSL database. Over.
All right, thanks, Nate. Brian, anything else that you'd like to chime in here as well on? Or has Nate basically covered it for you?
There was just something else I did think, and this is Brian. I know there's been discussion about, you know, can there just be one source for everything with, you know, related to that? And I think that answer is that would be wonderful, and let me know when that website gets loaded, because it'd be great. But in the meantime, there's so many different sources that maybe through the Department of Agriculture or FEMA or other federal agencies that may have information that just is another source to go to, depending on what your situation is in your area. And I think part of the reason why we like doing these trainings of the Climate Change Planning Handbook is to really get the students to understand there are resources also in your area, whether it's a major university that's doing a study or that has this database. You know, those are good resources too, and that could be one additional resource, you know, on top of ones that have been mentioned in this presentation. So you have a bigger picture that you're looking at from multiple angles to really best advise you in what direction you need to do and how you need to approach that project at MilCon, that, you know, planning phase or development. So I think if I were to say, it's just, there's no one-stop shopping for what is this climate change answer. There are multiple ones, and it's also based on your location. Like some of the ones outside the US, it may be harder to look at those sources because you may not have in the Far East or in Europe sources as easily available like FEMA or Department of Agriculture, just because that's not what they do. So your sources will be different, and there may be more partnership. And I think the big discussion with climate change and resilience is you're not working just in your simple, you know, department or cubicle. You're working across business lines, whether it's, you know, environmental or design construction. You're dealing with CPLOs and all these different people that all have a stake in this bigger picture. And I think the part of this I really do like is how much more networking and communication will continue through a topic like resilience. So that's what I wanted to add, but thank you.
Hey, Brian, I actually want to, this is Nate again, I want to tag back onto it real quick. So for the DCAT, you know, that it addresses many different climate indicators like coastal total water levels, coastal erosion, drought, desertification, wildfires, permafrost, all sorts of things. And then, we have to use many different sources like the DERSL, so we get that sea level rise scenario planning aspect. And something that the DERSL provides too is a wide range of timelines or timeframes, in addition to the multiple scenarios per time frame. And we're taking it at NAVFAC a step further, and we're doing the geoprocessing to transform the tabular data from the DERSL into GIS to better support the decision making. So I think no matter what, right now we're going to be using a variety of tools, but we're focusing, on the sole topic there of, how can we be more resilient altogether? Thank you.
Great, thank you, Nate, and thank you, Brian, as well for that answer. So I want to get a question here for Robert Warren here. This comes to us from Albert Romano, our head of the Resilience COI here at SAME. So he's asking, what are some of the challenges that you are facing in incorporating resilience at DoD installations to mitigate the potential impacts of sea level rise? Definitely a lot to unpack in there.
Right, thank you. So good question. Our biggest challenge, I guess there's more than one challenge here, but I guess first off is how we implement our criteria based on the International Building Code, and then the International Building Code adopting ASCE 24 for flood resistant design and construction. And then, working with the FY19 and FY20 NDAA, modifying the Freeboard Approach that's in ASCE 24, as well as creating a whole new approach to include sea level rise criteria into our final design flood elevation.
All right, great. Anybody else want to chime in on that? Otherwise, we've definitely got no shortage of questions here. All right. Well, I wanted to ask another question here for probably Sherry McMillian here, just so I think our attendees will appreciate it, about how do we access the criteria documents, and what sort of projects are these documents used for?
That is a great question. Thank you. Yeah, the criteria documents, the UFCs, the UFGSs, the portal that I saw answered in the chat, they're all available on the Whole Building Design Guide. So go to WBDG, stands for Whole Building Design Guide.org. And you can also I Google search UFC or UFGS, and it takes me there pretty quickly if you just pop it into Google. And then whatever projects are the UFGS is used for, they're used for all DoD projects. So they apply to the Army, Navy, Air Force, Marine Corps, and not just these military departments, but also to defense agencies. For instance, MDA, Missile Defense Agency, and all the agencies. The UFGSs and the UFCs have to be used, and that is according to MIL Standard 3007, and also UFC 12001 says this, so required by our policies.
Fantastic, thank you, Sharon. I saw Kristen put that link in the chat there as well. For everybody, you can grab it from there. So I think we've got time for just one more question here. We're just about out of time here. But I think we can squeeze it in here. So Robert Warren, I think this might be in your wheelhouse here as well. About MK asks about, how do you plan to address flooding on bases from extreme rain events? Do you plan on it? And if so, how are you planning on addressing this?
Well, so I guess the way we address rainfall now is we rely heavily on state criteria, and so we tend to find that the state criteria works out the best for us because different states have different rainfall amounts, and so their criteria can be different to accommodate the situation that they're in. So it works better than having a one-size-fits-all approach in the USC, where we can, when we rely more on the state criteria, we need different criteria, obviously, in some parts of California, than we do in Pennsylvania or Florida. So relying on the state criteria works fairly well for us. And, there's different based on your facility type, you might be using a 10-year rainfall event, or, that would be the most common, but if you get into designing something a little bit more critical, like a hospital or something, we would be using a 25-year rainfall event. If you're just designing a road, we might be looking at designing for 4 inches per hour, depending on your location. So, a lot of, I guess the big answer to that question is a lot of that depends on the particular location and the feature that you're trying to design for.
All right, thank you, Robert. And with that, we are out of time. Sorry if we couldn't get to your questions in here, but unfortunately, we've only got a limited amount of time. So thank you to everybody who asked questions, even if we weren't able to get to them. So thank you to Admiral Aguayo, and thank you to our entire panel of featured speakers here for your time today and for your participation. And thank you to all of our attendees for listening in. So please make sure to download, again, the copy of the slide deck, your PDH certificate, and a copy of the Climate Action 2030 from the Handouts tab before you head out today. If you're interested in submitting an article to the military engineer and possibly being invited to present at one of our monthly TME Presents webinars, please visit our website. You can find our editorial calendar and writer's guidelines there. If you're interested, our call for presentations for the upcoming 2022 Federal Small Business Conference is open until June 13th. You can find more information about both of these opportunities to share your expertise with SAME members on the SAME website. So on behalf of SAME, the military engineer, and our featured presenters, thank you all for joining us today, and have a great rest of your day, everyone.
Thank you, Daniel, very much, and thanks to all our partners.
Have a great day, everyone.